Welcome back, folks. This is going to be a short lecture where we introduce you to the chi-squared distribution. For starters, we denote a chi-squared distribution as the capital Greek letter chi squared, followed by a parameter k, depicting the degrees of freedom. Therefore, we read the following as variable y follows a chi-squared distribution with 3 degrees of freedom. All right, let's get started. Very few events in real life follow such a distribution. In fact, chi-squared is most featured in statistical analysis when doing hypothesis testing and computing confidence intervals. In particular, we most commonly find it when determining the goodness of fit of categorical values. That is why any example we could give you would feel extremely convoluted to anyone not familiar with statistics. All right, now let's explore the graph of the chi-squared distribution. Just by looking at it, you can tell the distribution is not symmetric, but rather asymmetric. Its graph is highly skewed to the right. Furthermore, the values depicted on the x-axis start from 0, rather than a negative number. This, by the way, shows you yet another transformation. Elevating the student's t distribution to the second power gives us the chi-squared, and vice versa. Finding the square root of the chi-squared distribution gives us the student's t. Great! So a convenient feature of the chi-squared distribution is that it also contains a table of known values, just like the normal or student's t distributions. The expected value for any chi-squared distribution is equal to its associated degrees of freedom, k. Its variance is equal to 2 times the degrees of freedom, or simply 2 times k. To learn more about hypothesis testing and confidence intervals, you can continue with our program where we dive into those. For now, you know all you need to about the chi-squared distribution. Thanks for watching.